Good afternoon, my name is Carla Mejia, and today we're going to talk about an experimental investigation of risk sharing and adverse selection. The members of the group are Gabriel Gonzalez, Johan Salinas, Nestor Zambrano, and me. The question to conduct our experiment was the following: how do difference in risk profile affect adverse selection and, in turn, hamper the effectiveness of voluntary risk sharing? So, this research engaged with behavioral economics by experimentally exploring individuals' willingness to share risk with others. Across statements, we vary how risk profiles differ between individuals. We find strong evidence for adverse selection if individuals' risk profile can be ranking according to the first order, stochastic dominance, and only little evidence for adverse selection if risk profile can only be ranking according to mean preserving spreads. This finding provides valuable insight into how preference and aptitude toward risk can influence economic decision and support understanding of the principle of behavioral economics. Next. What type of experiment was performed? In this paper, we use laboratory experiments to investigate the behavioral relevance of adverse selection. A major advantage of the experimental approach is randomization. Decision makers can be randomly assigned to risk profiles, so ruling out any endogenous bias. Another advantage is that participants can be informed about how their risk profile compares to that of others, so that this cannot be an obstacle for adverse selection. Even under these circumstances, however, it's still an open question whether selection effects will actually occur. Adverse selection places greater strong demands on the rationality of individuals. It's really of their exact ability to predict whether a risk-sharing arrangement will lead to favorable redistribution exposed. To do so required them to anticipate risk-sharing decision of others and to adjust their own decision accordingly. In description, in our experiment, we implement a setup in which 3 individuals simultaneously decide whether they want to share the risk. Risks are simple to outcome lottery and realization are independent across players. Individuals make shared decision before the risk materialize, and those individuals how decide to share their risk divide proportionally the sum of the realizing income among themselves. Across treatment, we implement different forms of risk heterogeneity by binding to how outcome of the lottery and the corresponding probabilities. Lotteries can vary only in mean outcome, leading to first order stochastic dominance relation, vary only in spread, leading the mean preserving spread relation, or vary in both mean and spread, leading to a simple compensate risk increase.
Methodology of the experiment. The methodology of the experiment consisted of the laboratory setting in which the participants were randomly assigned to the different treatments to the variant according to their assigned risk within the shared groups. The experiment consisted of the determining the risk preference and belief about the risk-sharing decision of others using the lottery choice tax. The participants were informed about their and other risk exposures, but faced uncertainty about the actual risk outcome when making sharing decision. The experiment was designed to investigate the behavioral relevance of the adverse selection in the context of the risk sharing and and to explore how individual risk preference and belief about the other risk-sharing decision influence their own risk-sharing behavior. Limitation of the experiment. The four most important limitations of the experiments are as follow. And number one, limited representation of the real world. The experiment was conducted in a controlled laboratory, which may not fully reflect the complexity and the dynamics of the real world. The risk sharing decision. Number two, the simplified risk scenarios. The use of the simple two outcome lotteries may oversimplify the nature of the risks in the real world settings. The experiment did not fully reflect the diverse and the complex risk profile that individuals encounter in the real risk-sharing situation. Number 10, one-time design and the lack of learning opportunities. The experiment was designed in the one-time fashion, which not allowed for learning and feedback the real world, the risk-sharing decision, the typical involved interactive the process and learning for the experience, which were not fully replicated in the experimental setup. Number 4, the sample size and composition. The experiment had a relatively small sample and was conducted with students. The limited sample size and specific demographic composition might restrict the generalizability of the results to border the population on the real world context. In conclusion, the limitation highlights the need for caution in the generalizing to the result of the experience to the real world context.
Results. Result 1. Risk sharing and risk. The study examined how risk is shared in situations where individuals' risk profiles differ. It's observed that in situations of equally distributed shared risk, there is little variation. In settings where risk profiles can be classified according to first-order statistic dominates, great variability in risk distributions is observed. Evidence suggests that adverse selection manifests itself when risk profiles are ranked according to certain and conservation different tiles. Result 2. Adverse selection and risk profiles. Adverse selection is found to be more pronounced when risk profiles are ranked according to first-order stochastic dominance. The presence of simple of increased risk mitigates this adverse selection effect. Result 3. Empirically and individually optimal adverse selection. The observed adverse selection is compared to the individual optimal adverse selection. It is observed that quantitatively empirical adverse selection coincided with individual optimal adverse selection. However, quantitatively adverse selection is less pronounced than would be expected or optimal risk distribution. Result 4. Risk profiles, early and strategic adverse selection. Intermediate risk type exhibit different degrees of adverse selection between treatments, indicating a strategic response to anticipate adverse selection. These types believe about the levels of risk sharing of other types are intuitive and actual behavior, supporting the idea of strategic adverse selection. In conclusion, for results, result 1, in situation of equally distributed risk sharing, little variation in risk distribution is observed. Variability in risk distribution increase in environments where risk profiles are classified according to first-order stochastic dominance. In conclusion, result 2, the adversarialism is more pronounced when risk selection profiles are classified according to first-order stochastic dominance. The presence of simple trade-off increased risk mitigates this adverse selection effect. Conclusion result 3. Qualitatively, the observed adverse selection matches the individual optimal adverse selection. Quantitably, adverse selection is less pronounced in relative terms in optimal risk distribution. And conclusion 4, intermediate risk types show different degrees of adverse selection between treatments, indicating a strategic response. These types believe about the levels of risk sharing of the other types are aligned with actual behavior, supporting the idea of strategic adverse selection.
The next step, what we did was to determine the differences between behavioral economics and the traditional economic models related to our paper. What I found the most interesting was that this paper understands the difference that exists between behavioral economics and the traditional economical models. So we know that adverse selection, this is a topic that is centered in this paper, is very related to the conventional expected utility theory that comes from the neoclassical economics or the traditional economics, as we can say. So this one that focuses on supply and demand and driving forces of the production. By the other side, we have behavioral economics that focuses on psychology and also modern theories that try to understand irrational decisions. So we saw in this paper that the authors recognize this aspect. So how do they show that they recognize it? Because they use risk procediments, risk processes in order to really say, hey, we have these biases, so we're going to take these mechanisms to avoid cognitive bias. That is what behavioral economics is about. So this is how like they try to confront this bias and all the things that behavioral economics explains. In order to see how the authors really try to show us how they confront the biases, you can see here how they make a risk sharing mechanism, and also they have an experiment set up. And they also try to use a lot of aleatory experiments in order to avoid the biases. And we can see here that they combine average mechanisms and ways to use aleatory in order to reduce the existing biases.